Good morning. Today I would like to talk to you about time series forecasting. There are many forecasting methods, but time series analysis is one of the most widely used forecasting methods. Okay. First of all, let's talk about what is a time series. Okay. Now let me show you a time series. Okay. So this is a time series. Okay. So on the one side you have period 1, period 2, period 3, etc. So these are time periods. They could be days, weeks, months, years, etc. And then you have an observed actual demand for each period. Let's say this is the actual demand in period 1, actual observed demand in period 2, period 3, etc. So this is a time series. When we talk about time series, we can work with time series in a tabular way using a table, or we work with time series as a graph. Okay? So in this course, we're going to work with time series both in tabular terms and as a graph. So what is the idea of time series analysis? The idea is a very simple one. The time series analysis says, look at the data, there must be a pattern in the data, and that pattern will repeat itself in the future. Okay? So once we identify the patterns in the data, we will just simply project those patterns into the future, and that will be our forecast for the future. Okay? So what kind of patterns can there be in the data? There are a few patterns. First of all, this is the simplest one. Okay? So let's suppose this axis shows you how much you sell at any given point in time. And you have a pattern like this where your sales is constant, so you sell a certain amount every period, but you just have some random fluctuations around this constant average. Okay, so the average doesn't change, but every period you sell a little bit more or a little bit less. Okay, so you have a constant average and some random error. Another pattern is you can have a trend. Okay, you can have an upward trend or a downward trend, doesn't matter. Here you start at a certain level and the average is increasing. Okay, there's an upward trend and there's some fluctuation around that demand. Okay, another pattern could be like this. So now we have a number of patterns here. So first of all, there's a downward trend. We can see that. And then there's a seasonality. There's a seasonal demand in addition to downward trend. And then there's some random fluctuations around the seasonal trend. Okay? So now the idea is, if we want to know what sales are going to be like in the future, we find the trends and extrapolate, which means that we're going to project the trend into the future. Okay? So, now, as we said, there could be no trend, constant mean, and some fluctuation. We said there can be a trend plus some random fluctuations. You can have seasonal patterns. I'm not going to talk about cyclical trends, but they're just like seasonality. So people have developed certain methods, forecasting methods, for each case. Okay? The idea is, if a particular method is used for one trend, it will not perform well for another case. So if you're using a method designed when there is no trend, you shouldn't use that method for seasonal data, okay? So there are certain methods for, let's say, when there is a trend, and those methods will not be sufficiently good when there is seasonality or cyclicality, okay? So today, I would like to talk about methods developed for forecasting when there is no trend, okay? So what are some of these methods? Now, the first method, excuse me, is called the naive method, okay? And it has a very simple formula, okay? Ft plus 1 equals d sub t, okay? So what does that mean? F stands for forecast, D stands for the actual observed demand, okay? And the subscripts indicate time, okay? So what does this mean? Forecast for period t plus 1, okay, equals demand for period t, okay? So what this means is that whatever we observed in period t will happen exactly in period t plus 1. In other words, today's forecast will be exactly like yesterday, and tomorrow's forecast will be exactly like today, okay? And as you can see, this is a very, very naive approach to forecasting, okay? So we start with the naive method. So, so this is our time series, and let's forecast using the naive method. And I apologize for the glare on the screen. So now, for each period, we need to know the demand for the previous period, right? So as a result, for period 1, F1, we need to know what happened in period 0. However, we don't have that information, so we cannot forecast period 1, okay? So the earliest period we can forecast is period 2, okay? So forecast for period 2 will be equal to D1, okay? So what is D1? D1 is 1600, okay? So forecast for period 3, okay, will be equal to F3, will be equal to D2, okay? Whatever or however much we sold in period 2, we will also sell the same amount in period 3. So in period 2, this is our demand, okay? So 2,200, okay? So, and then we go to period 4. F4 will be equal to D3, okay? This is gonna be 2,000. Okay. Just for clarification, this is D1, this is D2, this is D3, this is D4, etc. So you just basically take this number and carry it over to the next period. So for example, this will be 1600, here 2500, okay? So this is how you use the naive method as one of the alternatives, okay? So since this method is not particularly clever, people came up with different methods, okay? A second method that is very useful is simple moving average. Okay, so what is the idea behind simple moving average? The idea is simple. First of all, you select n. Okay, n tells you how many periods you will use. Okay, let's suppose I decided to use 2 periods. What I will do is I will take the average of the most recent 2 periods. Okay, n can be 3, 4, 5, 6, etc., any number. Okay, so for example, if n equals 2, that means I'm going to use the most recent 2 periods. So for forecast for t plus 1, I go back 1 period from t plus 1 to t, and then another period from t to t minus 1. So I have the most recent 2 forecasts, and I add them up, divide them by 2, which means I'm basically averaging the last 2 periods. Okay, so how does this work? Let me show you on the whiteboard. So let me erase this. Okay, this is a little bit off. So let's, just for clarification, so D1, this is D2, D3, D4, etc. So I'm going to show you how to do this with 2 periods and 3 periods. You can think of how to extend it to 4, 5, 6, etc. Okay. So if I set n equal to 2, that means for a forecast there has to be at least 2 previous periods. Okay. So I don't have that for period 1 and period 2. The earliest I can start to forecast is at period 3. So the forecast for period 3 will be equal to D2 plus D1 divided by 2. So I take the average of the 2 previous periods. Okay? For period 4, F4, I'm just going to average D3 and D2 divided by 2. Okay? And for period 5, okay, I take D4 plus D3 and divide by 2. Okay? So you'll continue like this. Let's just, for the sake of an exercise, let's plug in the numbers. So for period 3, I'm averaging this 2,200 plus 1,600 divided by 2. For the next period, I'm averaging this. For the following period, I'm averaging these 2. So the numbers that I average, the window is just moving from one period to the next. And that's why it's called a moving average. The numbers that I average just progress, iterate from one period to the next. So I'm looking at period 4. I take the most recent 2 periods, so 2,000 and 2,200. 2,000 and then 2,200 divided by 2. Okay? And for period 5, okay, I need to average 3 and 4. Okay? So this is 1,600 and 2,000. Divided by 2. Okay? So this is basically how you do simple moving average with 2 periods. Now let me show you how to do this with 3 periods and it's basically the same. Okay, so I'm just going to erase this to give myself some more space. So instead of 2 periods, I'm going to need 3 periods. Okay, so that means I cannot forecast for the first 3 periods. I can only start at F4, period 4. Okay, let's just forecast for period 4. So what I need to do is I need to average D3, D2, and D1. So this is D3 plus D2 plus D1 divided by 3. Okay, I add up 3 numbers and divide them by 3. Okay, for period 5, I'm going to do the same thing. I take the most recent 3 periods because n equals 3. So D4 plus D3 plus D2. Divide by 3, whatever that number is, etc. So let's do F6. So I'm going to take D5, D4, and D3. So let's plug in the numbers just for the sake of an exercise. So for period 4, I average these 3 numbers, 2,000, 2,200, and 1,600. Okay, so 2,000 plus 2,200 plus 1,600 divided by 3. And whatever that number is. Okay, I'm not interested in this specific number. So for the next period, I move the average here. I take the average of these 3 numbers. So for F5, I average D4, D3, and D2. Okay, so 1,600, 2,000, and 2,200. So 1,600 plus 2,000 plus 2,200 divided by 3. Okay, and you can calculate that number on your own. For period 6, I need the most recent 3. Okay, 2,500, 1,600, and 2,000. 2,500 plus 1,600 plus 2,000 divided by 2 equals whatever that number is. Okay. Now, this is how you do a simple moving average with n equals to 2, 3, 4, etc. Now, one assumption in simple moving average is that every period that you use in your forecast is equally relevant to the future. Okay, so now if we're looking at period 3, we say period 2 and period 1 are equally similar to period 3. Okay, now there may be a case where D2, period 2, can be more similar to period 3 than period 1, because this is more recent and this is less recent. Okay, so more recent information may be more informative and representative of the future than less recent information. Okay, so the idea is we can put more weight on more recent observations than less recent observations. Simple moving average places the same weight, the same importance on all of the observations. Okay, so to give them different observations, what we do is we let's do this whiteboard also. We use a different formula. Okay, we do weighted moving average. Okay, so I'm just going to explain it with an example. So let's suppose we're using n equals 2. So we're averaging 2, or we're using the most recent 2 periods. But we want to weight one observation by 60%. So this is 60%. And the other observation will be 40%. Okay? So how are we going to do this? There's a kind of not a typo, but I would prefer to use these as follows. So W1 and W2. Okay, so we're going to use 2 periods, and for each period I need a weight. For example, if I use 3 periods, I would need 3 weights. So if n equals 3, okay, I would need W1, W2, W3. Okay. Now, what do these weights mean? W1 means you go back 1 period. Okay. So let's suppose I'm forecasting period T. Okay. I'm gonna weight period dt minus 1 by W. Okay, W1. So I go back 1 period from T to T minus 1, and this is the weight I'm going to use. Now, I use 3 periods. I go back 1 period, I go back 2 periods, and 3 periods. So I need to use dt minus 2, dt minus 3. So I go from period T, I go back 1 period, 2 period, and 3 periods. Okay? And the corresponding weights are like this. Okay? So here I use 2 periods, I go back 1 period, and I use this weight for dt minus 1. And I use this weight for dt minus 2. Go back 1 period, go back 2 periods. Okay? So what is the forecast going to be like? First of all, I cannot generate a forecast for period 1 and period 2. I can start at period 3. Okay? Oh, before I forget, these weights have to add up to 1. Okay? So for period 3, I'm going to use D2 and D1. Okay, so from period 3, I go back 1 period. Okay, and I go back 2 periods. Okay, so let me write the same formula for period 4. I go back 1 period from 4 to 3. Okay, and then I go back 2 periods, W2. 2 periods from 4 brings me back to period 2. Okay, for period 5, okay, go back 1 period to 4. Go back 2 periods, 3. Okay, and so on and so forth. Okay, so just as an example, let's plug in the numbers. Okay, so let me rewrite this in a bit more compact way. So W1 D2 plus W2 D1. So I'm going to use these 2 periods to forecast period 3, and so 2,200 will be weighted more, okay, because it's most recent, W1, W2. Okay, so 0.6 times 2,200 plus 0.4 times 1,600. whatever that number is. Okay? So this is more recent. It gets 60% weight. This is less recent. It gets 40%. Okay? So for period 4, I do the same thing. 0.6, 0.4. Okay? So I multiply 0.6 with the most recent period, which is D3, 2000. So this is 2000. And I go back 2 periods, 2200. Okay. Whatever that number is. And let's do F5. Okay. So I use D4 and D3. Okay. Equals, this is 0.6, 0.4. Okay. So most recent demand, D4, is 1600. Okay. And I go back 2 periods, 2000. So as you can see, it's just like the simple moving average, and the only difference is you place different weights on more recent and less recent periods. Okay? So another important and very widely used technique is simple exponential smoothing. Okay, so what is the idea here? Now, in simple moving average, we don't always get close to the actual demand. So when we generate forecasts, we will almost always be off by a little bit. Okay, so what this means is that for each period, we will deviate from the actual sales. So this is called the forecast error. Okay, let me jump ahead a little bit. Forecast error. Okay, so forecast error means the difference between the actual observed sale and your forecast. Okay, so for each period, we can calculate a forecast error. Now, what we don't do with simple moving averages, we don't learn from our mistakes. In other words, we don't use the forecast error to improve our forecast. Now, in exponential smoothing, we do that. Okay, what does exponential smoothing do? It does correct the forecast by the forecast error. Okay, so first of all, what we can see is every forecast is based on the previous forecast. For example, for period t plus 1, we start with the forecast for period t. Okay, every forecast is first and foremost based on the previous period's forecast. Okay, plus we add a correction term. Okay, we correct this forecast by this term. Okay, now what is this term? If you look at it, this is the forecast error. This was our forecast, and we were off by this amount. This forecast has so much error. Okay, and we add this correction term to this forecast to improve forecast quality. Okay, and this alpha is a number between 0 and 1, and it is called smoothing constant. Okay, must be between 0 and 1. Okay, so how does this work? Let me show you with an example. Okay, so let's suppose this is our time series. For the exponential smoothing, you need two pieces of information to begin. Okay, first you need alpha, okay, and then you need a beginning forecast, okay, F1. Now, just for off the top of my head, I'm just going to say 0.5. It's a simple number, okay, 0.5. And again, for simplicity, let's suppose I pick 2,000. Okay. So the idea is the forecast for period 1 is 2,000. Okay. So this is F1. This is F2. This is F3. This is F4. Okay. So I'm given F1. It's 2,000. Okay. Demand for period 1, 1,600. Forecast for period 1, 2,000. What can I do now? I can calculate the error for period 1. How far off am I in period 1? Okay. So this is very simple. D1 minus F1. D1 minus F1. So what I have here is 1,600 minus 2,000 equals minus 400. Okay. So now the error can be positive or negative. Okay, and that has a meaning. So what does it mean? Now in this case it's negative. So let's look at the actual demand and forecast. We see that our forecast was too high. Okay, so in order to improve the forecast, we need to bring it down. Okay, so that's why we have a negative error. Negative means your forecast was too high, let's bring it down a little bit. Now, if this was positive, that would have meant that we were too low. We need to bring up the forecast. In that case, this would be positive. Okay? So now F2 will be F1. Okay? F2 will be based on the previous forecast. So F3 will be based on F2, F4 will be based on F3. Okay? Every forecast is based on the previous forecast, plus a correction term, plus alpha, plus alpha, plus alpha, times the forecast error, okay, which is this, D1 minus F1. Now, for period 3, we're looking at period 2. And what is the forecast error in period 2? D2 minus F2. For period 4, we're looking at period 3. And what is the forecast error in period 3? D3 minus F3. Okay? And so on and so forth. Okay? So let's plug in the numbers. Okay? So for F2, my forecast will be 2,000. Okay? Because F1 was 2,000 plus 0.5 times minus 400. Okay? So this is F1, alpha is 0.5, the forecast error is minus 400. Okay? So we need to bring down the forecast a little bit, and it turns out to be 1,800. Okay? So our forecast was 2,000, which was too high. So we needed to bring down the forecast a little bit, hence the negative forecast error. So we went from 2,000 to 1,800. Okay. Now, how are we doing now? Actual demand is 2,200. Our forecast is 1,800. So now we went down, but we went down too much. So we need to bring up the forecast. So if we're too low, the forecast error should be positive. Okay, let's calculate that. Okay, so error 2 will be D2 minus F2. Okay, so D2 is 2,200, and F2 equals 1,800. And now the forecast error is 400. It's a positive number, just as we expected, because we were below the actual. We were too low, so we need to bring up the forecast for the next period. Okay, so let's do the forecast for period 3. Now it's going to be based on F2. F2 is 1,800 plus 0.5 times D2 minus F2, which is 400. Okay, so what that means is this is going to be 2,000. So now, as you can see, our forecast went from 1,800 to 2,000. Why? Because we were too low. This was too low. So we increased the forecast as a result. Okay? So you can just keep on working through this formula like this. Okay? So now, at this point, you may be wondering, so how do you pick alpha? How do you pick the initial forecast? How do you pick n? Okay, there is no scientific way to determine these values. Okay, what people do is they try different alphas. They try different n's, and they pick the one that seems to work best. Okay, so how do I know which one works best? Well, we can measure forecast quality, and we can find which alpha gives us the best forecast quality. Okay, so now what is forecast quality? Now let me talk about forecast quality now. Forecast quality can be measured in different ways. Okay, there is no single measure of forecast quality. There are multiple measures of forecast quality. Just like if you think about the financial performance of a firm, there are different types of financial ratios. There is no single number that describes the entire financial situation of the firm. Similarly, there are multiple measures of forecast quality that evaluate the forecast from different perspectives. But one thing that all forecast quality measures have in common is all of them are based on the forecast error that we just talked about. Okay, the forecast error equals demand minus forecast. Okay, so what we can do is we can calculate the forecast error for each period. Okay, let's suppose this is a simple time series, and these are my forecasts. So for period 3, this is the actual, this is the forecast. Period 4, actual forecast. Period 5, actual forecast. Now, how far off are we for each of these periods? Okay, so I take the actual demand and subtract from it forecast. Okay, so 70 actual minus 90 forecast equals minus 20, actual 90, forecast 75, 90 minus 75, 15, actual 80, forecast 80, perfect, 0 forecast error. We're right on, okay? So these are the forecast errors. The first forecast quality measure I want to talk about is mean forecast error. Basically, I calculate the forecast error for each period, and then I average them. Okay, I take the average of minus 20, 15, and 0. Okay, so basically the average is minus 1.67. So what does this mean? Okay, the mean forecast error, MFE, measures the average of forecast errors, okay, and it is a measure of bias, but not a measure of accuracy. Okay, what does bias mean? Bias means that are you consistently over forecasting or under forecasting? Now, ideally, you should target the actual sales, and if you are not biased, you should have positive errors half the time and negative errors about half the time. Okay, so sometimes you will be over forecasting, sometimes you'll be under forecasting, but on average, you should not have a bias to be above or below the actual. Okay, so if you're unbiased, you should be equally over forecasting and under forecasting. And when you average the forecast errors, if you're unbiased, you should be close to 0. Why? Because you should have about an equal amount of positive and negative errors, and they should cancel each other out. Okay? So ideally, if you're close to 0, your mean forecast error, if your mean forecast error is close to 0, you're relatively unbiased. But if you have a large positive number or a large negative number for your mean forecast error, that means you're biased one way or the other. Okay. Now this measure points to bias but not accuracy. Why? Because you could have two large forecast errors, one positive, one negative, and then they would cancel each other out, and this would come out very close to 0. Okay. So how do you measure accuracy? To measure accuracy, you should prevent positive and negative errors from canceling each other out. Okay. So what that means is that you need to take the absolute value of forecast errors and to take the average of absolute value of forecast errors. Okay, so how does this work? Let me show you. Okay, so now we have calculated the forecast errors for each period. Now I take the absolute value. The absolute value function is very simple because negative numbers become positive, positive numbers stay positive. Okay, so nothing happens to 0 and 15, they stay the same, but when you apply the absolute value function to minus 20, it becomes plus 20. Okay, so this is how much off I am from the forecast. Okay, it doesn't matter which direction, it's all positive. So when I take the average, okay, it comes off around roughly 12. Okay, on average, this means if I pick a random period, okay, I will be off by 12 points or 12 units. Okay, so this is mean absolute deviation. Okay. So mean absolute deviation measures the dispersion of forecasting errors, and ideally you would like a smaller mean absolute deviation because it shows that you're closer to the actual demand. If you have a larger mean absolute deviation, it means you're farther off on average. Okay. Similar to mean absolute deviation, there is also mean squared error. Okay. So what does mean squared error do? Instead of averaging the absolute values, you average the square of forecast errors. Okay. So that way, everything becomes positive. Okay. Let's look at this. Now we had minus 20, 15, and 0. Okay. Now, if we square each of these, we get the following. So minus 20 squared equals 400. 15 squared equals 225. 0 squared is still 0. Okay. So now I have the square of each forecast error. And then I take the average. Okay. So you may be wondering, what's the difference between taking the absolute value and the square? In both cases, all the errors, forecast errors, become positive and they stop canceling each other out. The difference is when you square a number, larger numbers, the difference between smaller and larger numbers get amplified. Okay, so here the deviations, small and large deviations, have a certain proportion to each other, but here that difference is magnified, enlarged. Okay, so so this is all good and well, but so far we have just looked at how many units off you are from the actual. Okay, what this means is that you don't have a sense of scale. So let's say you're off in your forecast by $1 million. Okay, you're off. Your forecast is off by $1 million. Okay, is this a big forecast error or a small forecast error? You can't really tell, right? So you need something to compare your forecast error to. Okay, and that you can do using mean absolute percentage error, or MAPE. This is extremely popular. So how do you do that? You take the absolute value of your forecast error and you divide it by the actual demand. Basically, this is what percent off you are from the actual. It's not like how many units off are you, it's like what percent are you off. Okay? So, so let's look at this. So now I have the absolute value of my forecasts and I have the actual demands. Okay? I was off by 20 units from an actual of 70 units. What percent off am I? I take 20 divided by 70. Okay, 20 divided by 70 is 29%. So in period 3, I was off by 29%. Okay. Now in period 4, I was off by 15 points or 15 units from 90. What percent off am I? 15 divided by 90, I'm off by 17%. Okay. In period 5, I'm off by 0. Okay. So that means I'm off by 0%. So, and then I take the average of all these percent deviations. Okay. And I get the mean absolute percentage error. So on average, I'm off by 15%. Okay? So now, these are the four measures of forecast quality. Now, in this class, we have seen different time series methods, and there are others we haven't talked about, and we have seen how to calculate forecast quality measures to evaluate these methods. Okay? Well, this should be good enough for you to do your first assignment. And if you have any questions, as always, feel free to contact me.